solving systems using substitution. It's like putting together a puzzle. And I'll explain as I go, I suppose. So step one, we have our system here. Two equations. And we're trying to find that shared point where they come together, like we learned in the last video. But we're going to try and find it without graphing. We're going to try and find it using just math, just algebra. So my system here, I've labeled my two lines, line 1, line 2. Both of them are solved for y. So my first line, I have y is equal to 2x. My second line, y is equal to x plus 5. Or y is equal to this, and y is equal to that, using the method of substitution. I'm going to put this and that together. So now that this is equal to that. Now that I have them set up together, I can, in one equation with one variable, I can solve for x. So I'm going to subtract x from both sides here. On the right side, those x's will cancel. On the left side, I have just plain old x. So x is equal to 5. In order to solve for y, I plug in 5 into one of the equations. I'm going to choose equation number 1. And in the place of x, I'm going to substitute in a 5 so that y is equal to 10. Lastly, I bring it all together as an ordered pair. When we graphed these equations in the last video, the two lines came together at a shared point. And that point was the solution to the system. Same thing when we're solving mathematically. We come to a shared point, a point that is on both lines. Down here, I'm going to check my solution by plugging it into both equations. So here, using a t-chart, I've got y is equal to 2x. I'm going to plug in 10 in place of y. And I'll plug in 5 in place of x. And this checks. I'll do the same for equation number 2. So this tells me that that point lies on both lines. Now I'm going to double check using Desmos. Here's my first line, y is equal to 2x. My second line, y is equal to x plus 5. There's my two lines together. I can't quite see the point where they intersect, so I move my graph. I put my finger right there where the two come together, and the solution is 5, 10. So we found 5, 10 solving mathematically and by graphing. All right, now we're going to use substitution for another example. So here I've got 2x plus y is equal to 5, and y is equal to x minus 4. In this example, equation number 2 is solved for y. Equation number 1 is in standard form. I'm going to take that equation that's in standard form, and in place of y, I'm going to substitute x minus 4. Combine like terms. Add 4 to both sides. And I have 3x is equal to 9. Divide both sides by 3. X is equal to 3. Now remember, I'm looking for an ordered pair. So an x solution and a y solution. So here I have my x, and in order to find y, I'm going to need to plug that into one of the equations. I'm going to choose equation number 2. I'll plug in 3 in place of x. And I have y is equal to -1. So now that I have my x and my y, I bring it all together. My solution is going to be 3, -1. Double check that on Desmos. We're going to have to convert that first equation to slope-intercept form. Regular Desmos, you can just type it in the way it is. Testing Desmos, nope. So over here on the side margin, I'm going to take that 2x plus y equals 5, and I'm going to solve it for y. So subtract 2x from both sides. Now I skipped a step or two to come up with that. If you want to see it in slow motion, here we go. Subtract 2x from both sides. Bring down the y. And I have 5 minus 2x. And that's fine. That right there is fine for Desmos. Proper form, proper slope-intercept form, you're going to write your slope first and then your y-intercept. So this right here. We're going to put that into Desmos. That's our first equation. And we're also going to use our second equation. All right, so line 1, y equals -2x plus 5. And line 2, y equals x minus 4. I have both the lines graphed. I'm going to zoom in on that, put my finger at the point where they come together, and I get 3, -1. 3, -1. So that checks. It jives. Critical thinking question. Explain the connection between the solution of a system solved by graphing and the solution of the same system solved by substitution. Words, words, words. What did all those words mean? Well, it means that your point of intersection is going to be the same whether you graph it or use math to figure out your solution. So if you're using substitution and you're solving mathematically, you'll get the same thing as if you graph it out. And here again, we're going to use substitution. And this time I'm going to solve them both for x, because that looks to be the easiest thing to do. I just move that 4y to the other side on the first equation, and on the second equation, I'm going to push y to the other side. like that. So now I've got both of my equations solved for x. So x is equal to this, and x is equal to that. I can put those together, equations 1 and 2, so that I have negative 4y plus 6 is equal to negative y plus 3. Next step, add 4y to both sides. So here I had a variable on both sides of the equation. I need the variable to be on just one, so I move my smallest variable, which is the negative 4y. I move it by adding it. Okay, still trying to isolate that y. It's y's party. 3 is the best friend. Plus 3 is also at the party, but it's party's over, time to go. So we're going to subtract that from both sides. And extend this line. Three y is equal to 3. Divide both sides by 3. Y is equal to 1. So all that work, and I now have the value of y, and it sure took up an awful lot of space in my paper. Now I need some room so I can solve for x. So I'm going to take either equation 1 or equation 2. I'm going to use equation 2 and plug in. I'm going to use this equation 2, my new equation 2. This is my old equation 2, but I'm going to use new equation 2. So I take new equation 2, plug in that 1. X is equal to 2. All right, so I plug in, or I'm building my ordered pair here. So my x value is 2, my y is 1. That's my solution. I can check this on Desmos also, but I'm going to have to turn both of these equations into slope-intercept. Got to do that first. All right, so my first equation, got x plus 4y is equal to 6. And I'm putting this in slope-intercept.
I'm going to move the x to the other side, and then divide everything by 4. So when I divide, I'm just going to put it underneath here. 4y divided by 4 is just plain old y. 6 over 4, that's going to simplify to 3 halves. And then x over 4, that's going to be 1/4 x, like that. Turn this around so it's proper form here, proper slope-intercept. And this is what I'm going to put in the Desmos.
Equation number 2.
Just subtract y, or excuse me, subtract x. Turn that around. There we go.
All right, our solution is 2, 1. That's what we're checking in Desmos. So I have my 2 equations ready to go. They are Desmos friendly.
The first equation equals, and the slope is a fraction, so I gotta remember divided by 4. Plus, the y-intercept is also a fraction, 3 divided by 2. Okay. Second line, y equals negative x plus 3. So there's the 2 lines graphed. I zoom in, put my finger on the spot where they come together, that's 2, 1. I can zoom out and see both the x-axis and the y-axis. I can hit the home button over here on the right, and that lets me see everything 2, 1.
Perfect. All right, so I have my lines labeled 1 and 2. And I'm going to take equation number 2 and solve for x. Why? Because all I have to do is push that 4y to the other side by adding it. There we go. That was easy. Then I'm going to take the first equation, and in place of x, I'm going to plug in that 4y plus 11. So I just took this and put it here. Substitute. Okay, now I have one equation with one variable in it, which is, that was the goal. And I distribute. Like that. Combine like terms.
Okay, combine those. So 4 and negative 20, that's negative 16. Then I'm going to add the 55 to both sides. I'm writing pretty big. You may not want to write so big because we're about to run out of room here. That's going to equal 64. Divide both sides by negative 16. And you get y is equal to negative 4. Am I done yet? Nope. What's left to do? Solve for x. I have my y. I'm going to plug that y in to somewhere. I can plug it back in right up here. So I'm taking equation number 2, my new equation number 2, and I plug in the y so that I can solve for x. That's going to be negative 16 plus 11, and negative 16 plus 11 is negative 5. So x is equal to negative 5.
Are we done yet? Almost. Put it all together. And the solution is the ordered pair. X, y. So negative 5, negative 4. All right, let's check that on Desmos. Before we check it on Desmos, we've got to put together our equations in slope-intercept form.
So here is equation number 1. Add the x, 5x to both sides. Divide everything by 4. Equation number 2. I'll highlight this first. Equation number 2, I am subtracting x from both sides and then dividing everything by negative 4. Phew. That one's going to be crazy on Desmos right there. Okay. Alright, so the first equation, y equals 5 divided by 4. X plus 9 over 4. Oops. Okay, the equation is slope of 1/4 minus a y-intercept of 11/4. Wow, you see we got a couple of lines here graphed. We're going to have to move this around in order to find where they come together. So they come together right here at negative 5, negative 4.
If you'd like to see the challenge problem, then let's go. All right, so our challenge problem, we have 3 equations. How many variables are there? How many different variables? You've got x, you've got y, you've got z. 3 variables, 3 equations. And that's how a system works. If you have 2 variables, like x and y, then you need 2 equations. If you have 3 variables, then you need 3 equations. in order to solve.
Equation 2 and 3. I'm going to solve both of those for y. So equation 2, I'm going to subtract c from both sides. And equation 3, I'm going to solve for y also. Add 4z to both sides. Solving for y. Divide everything by 2. Okay, so now I have y is equal to this, and y is equal to that, and I'm going to put this and that together. Add c to both sides. First time I solved this problem, I did it differently, and I'm going to show you that in a second. Because there's always more than one way to solve a math problem. Add 7 to both sides. Divide both sides by 3. So the hardest part here is solving for the first variable. Once you get that first variable, then it's really just plugging stuff in. So I'm going to take my z value, and plug that into equation number 2. Equation number 2, I have y plus z, which is 4, is equal to 5. Now what in the world plus 4 is going to equal 5? Well, 1, of course. Y is 1, z is 4. Now I can plug this into equation number 1. X plus y plus 2 is equal to 7. Subtract 3 from both sides. X is equal to 4. Put it all together. Solution here is x, comma y, comma z.
Okay, Desmos does not do a 3-axis solution. Desmos will only do x and y. So if we want to see this solution, we're going to have to use GeoGebra, which is so much cooler. But also you cannot use GeoGebra on, a state test. Can't use it on the star, but it is so cool to just see it. All right, so this is GeoGebra, and GeoGebra will allow me to use 3 axes, the x, the y, there's x and y, and also z. My first line, x plus y, plus 2 equals 7. Enter. And it graphs not just a line, it graphs an entire plane. You remember that term from geometry. Second plane that I'm graphing, y plus z equals 5. Third plane, 2y minus 4z equals negative 14. Enter. I'm going to spin this around for a second so you can see all 3 of those planes. Now the point where all 3 of them come together, which looks like it's in here somewhere, it's at 4, 1, 4. That is our solution. I can change the color here in GeoGebra. I don't want to mess around with this too much because I'm going to wrap up this video.